Good morning, Geometry Semester 1 students. So this one is a pretest analysis for Unit 2. So now we'll take a look at this. So the first question is asking about which of the following its proper name for the figure below. So there are three ways to name the triangle. You can say that it's JKE or EKJ, or the other one is EJK. So the way to name the triangle, it's about using the vertices or the points, not the line segments. So that's why we have used those letters on the points. So the correct way to call this triangle is JKE. So here's another one. So it's either named as ATX or XTA or AXT. So the one that's on the, according to the list, what we got is ATX. Okay, so we can skip that one. So it's quite similar. So which of the following correct name a size of a triangle below? So in order to name the side without the exact value, so we need to put a bar on top of the line segments. So this one would be considered segment AB. Point B, we don't use that. That's not a line segment. That's not a side. Angle C, that's just the angle. It's not a line segment. And triangle ABC is just describing the two-dimensional plane. So here's another one. So name the angle. So there's only one selection. It's angle C. And which of the following correct name one of the vertices of a triangle? So point M, vertice, that means the points. So which of the following is a right triangle? So right triangle, that means it contains a 90-degree angle. So then that'd be triangle C. Which of the following? It's an obtuse triangle. So obtuse triangle, that means one of the angles is greater than 90, but it's less than 180. So the answer is B, because that contains 125. Well, 126, excuse me. And which of the following is a Q angle? So that means all the angle got to be less than 90, but it's greater than 0. So it's triangle A. So it's selection A. So triangle ABC has a side length of the measure 10 centimeter, 10 centimeter, 15 centimeter. So anytime they see that the two sides of a triangle are exactly equal, so that means called the isosceles triangle. So triangle XYZ has a side length of measure 20 centimeter each. So it's all three sides are equal. That means it got to be called the equilateral triangle or the equiangular triangle. None of the sides are equal, so if a triangle, so that means called the scalene triangle. So I'm sure you guys are pretty familiar with this. And then triangles, a right triangle with the leg measure 5 centimeter and 12 centimeter. Which of the following is the measure of the triangle's hypotenuse? So if that's a right triangle, so that means we can apply the Pythagorean identity. So one is 5, the other one is 12 for the side length. So in order to find the longest leg, we can use the triangles, the Pythagorean theorem. Okay, so let me just highlight this one. So then I'll show that the way to show work for this. Okay, so copy and paste. Okay, so the Pythagorean theorem, also you guys are pretty familiar with that. It's considered a square plus b square equals c square. So the shortest leg, what we got is 5. So a is 5 square, so b squared, then that'd be 12 square. Hypotenuse, it's always the longest leg. So the longest leg, so we have a right triangle like this. So 5, 12. Excuse me, so let me just erase this. So now 5 squared, which is 25. 12 squared is 144. Combine them together, so we do have 169. And then square root of both sides, so that means C is 13. It's a perfect square number. And that's what we got for this one. Another one, so again, so using the Pythagorean theorem, so make sure that you plug in the number correctly. So 17 inches, and other side measures 9 inches. Which of the following is the measure of the third side? So this one is showing that the longest leg of the right triangles, it's 17 inches. So the other two sides, okay, let's see. It doesn't say what kind of triangle this one is. So that's a weird thing. Let's see. Yeah, so assuming that's a right triangle because all three sides. Yeah, this one's supposed to be measuring that the type of a triangle. So there's some kind of structural problem. Okay, so pretty similar to the previous one then. And now question number 6. So in the figure below, what's the value of x? So this one we'll use that the triangle sum theorem. We do know that the measure of all the angles, once you add them all together, so the sum is always 180. So basically you can just combine that 115 and 12 together, so you'll get 127, and then you subtract from 180, so you'll get 53 for the measure of angle x. So again, triangle sum theorem. So this one too, triangle sum theorem, you'll get the third angle, 62 degree. And this one right here, get the vertex angle, you'll get 26. And number 7, so this one, it's about the congruent triangle. So congruent triangle showing that all the angles, they're considered equal or congruent. So angle B is 94, so that means angle E is also 94. Angle C is 39, angle A. So we can use that the triangle sum theorem. So we'll get 47, and which is the same as angle D. So that one too, use the triangle sum theorem to figure out what angle V is. And then once you get that, and you can set it equal to angle Y, because those are the congruent triangles. So one is upside down, the other one is just like facing upward. Same thing happened with 7C. Okay, so now what about for number 8? So which of the following are interior angles in the figure below? Interior angle, so that means it's inside the figure. So what we got here, it's angle 1, angle 2, angle 6. So the figure, what we got here is a triangle. So inside the triangle, we do have angle 1, 2, and 6. So here's another one. So which of the following are the remote interior angles of angle 4? Remote interior angle, so that means the sum of the other two angles, it's the same as angle 4. So what we got here, so we got angle 1 and 2. Well, because that angle 6 is right next to angle 4. So it shows like a supplementary relationship. So one thing that you notice, angle 4 plus angle 6 is 180, and which is the same as angle 4 plus angle 2 plus angle 1. Well, angle 4 is the same as angle 1 plus angle 2. So which of the following are the exterior angles in the figure below? Exterior angle, that means outside the polygon, outside the triangle. So we got angle 3, angle 4, and also perhaps angle 5, but it's not listed. Number 9a in the figure below was the value of x. So this one we need to use the remote interior angle theorem, as you may notice. So 100 degree is the same as the measure of angles x and plus 68. So the way to find x, so you can just subtract 180. Well, not subtracting from 180, subtract 68 from 100 degree. So the answer would be 32. Again, the remote interior angles of 100 degree, it's angle x and 68. So 68 plus x equals 100, and then you solve for x. So same thing happened with this one. So angle x plus 62, so that equals 93. And then solve for x, you get 31. Okay, so that one too, we can skip along. What's the maximum number of the obtuse triangle? Obtuse angle a triangle can have. In order to have obtuse triangles, so there's only one angle is considered obtuse, because the sum of all the angles of a triangle is 180. So you cannot have more than one obtuse angle in a regular triangle. So what's the maximum number of a right angle that can be contained in the triangle? Just one. Again, the measure of all the angles in the triangle is 180. So you take 90 degree, the rest of those two angles got to be 90 degree. Since the triangle below contains the obtuse angle, what type of angle must angle x be? Acute. Again, there's only one obtuse angle allowed in a triangle. That means the rest of those angles got to be less than 90, but it's greater than 0. Question 11. So which statement must be true if triangle JKL is congruent to triangle MNP? So one thing that we notice, okay, so this one, if you find out something that doesn't match, JN, it's congruent to MN, while they're not even considered a congruent segment. So the only thing that matching is that angle K is congruent to angle N. Again, the rest of those selections, they don't even match. Angle J, angle P, they're not even considered as a corresponding angle. And also JK doesn't even match with MP. So here's another one. So which statement must be true if triangle RST is congruent to triangle XYZ? So find out the one that's matching. So segment RS is congruent to segment XY. Okay, so that one's two. So given that triangles ABC is congruent to triangle DEF, which of the following must be true? So this one you want to match the letters. So angle A is congruent to angle D. Angle B is congruent to angle E. So the selection will be found here, the one that's true, the only one that's true, which is what? Selection C. So again, finding the one that's considered the matching letter. So angle A is the same as angle X, angle B is the same as angle Y, angle C is the same as angle Z. So C is 32, that means angle Z is 32. Segment similarity, so XY, so what we got here is the same as AB. Again, you want to find out the matching letters, the first two. So which property best describes the congruent statement below? Triangle ABC is congruent to triangle ABC. If that's the same triangle, so that means a reflexive property. Anytime they see the same element appear, so that means it's considered a reflexive property. If see like a symmetric property, so that means it's considered two different elements. So triangle ABC is the same as triangle DEF or congruent, which is the same as triangle DEF is congruent to triangle ABC. It's symmetric. It shows that the symmetrical relationship. Transitive, that means it's three different elements. So triangle ABC is congruent to triangle DEF, and triangle DEF is congruent to triangle GHI, the third element. So therefore, triangle ABC is congruent to triangle GHI, so it's transitive property. Okay, so now let's see what else that we have for the rest of this. So question 14, so this one is showing that the translations. So which transformation can verify congruence by slide one triangle over another? So that's translation. If that's a sliding, the keyword, it's always translation. If that's turning with the angle, then that'll be considered rotation. Reflection, that means the keyword flipping. Proof, so this one showing that all three